Hello friends, this is Gangadhar from Maths Gangadhar. This is another question asked in JEE Advanced 2019 paper 1 under more than one correct answer type questions. So the question is about a function f which is from R to R given by in different regions like this, and we need to check which of the following options are correct. See, two options are about the nature of f dash and two options are about the nature of f. See, for that, initially what I am going to do is, this is the function. See, for x less than 0, in between 0 and 1, in between 1 and 3, and for greater than 3. See, first of all, check whether the function is continuous or not. See, if we move towards 0 from the left hand side, then we may have to use this function. See, then its value is 1 clearly. Then if you move towards 0 from the right hand side, then we have to use this function. Here it also, the functional value is 1. So f of 0 minus as well as f of 0 plus is 1, so it is continuous at 0. Similarly, at 1 if you check, this value is 1 minus 1 plus 1, again it is 1. And at 1 if you check here, see, this will be 2 by 3 minus 4, see this value at the 1, so 2 by 3 minus 4 plus 7 minus 8 by 3. 7 minus 4 is 3, 2 minus 8 minus 6 by 3 is minus 2, and this is 1. So from the left hand side of 1 it is 1, in the right hand side of 1 also the functional value is 1. So the given function is continuous, x is equals to 1 also. Then again you need to check in the left hand side of 3 as well as in the right hand side of 3 for the functional value of f. See, in the left hand side of 3, if you replace 3 in the place of x, you will get that 2 by 3 of 3 cube minus 4 into 3 square plus 7 into 3 minus 8 by 3. So, if you observe it, 1 3 will get cancelled, 3 square is 9, 2 into 3 square minus 4 into 3 square is minus 2 into 3 square plus 7 into 3 minus 8 by 3. 9 2s is 18 plus 21 minus 8 by 3. 21 minus 18 is 3 minus 8 by 3. 3 3s is 9 minus 8, and this value is 1 by 3. So if we move towards 3 from the left hand side, the functional value is 1 by 3. Similarly, if you check for the right hand side value of 3, you need to replace 3 here. So if you replace 3 here, it will be 3 minus 2 is 1, and then log 1 base e minus 3 plus 10 by 3. This is 0. See, 3 3 is 9, 10 minus 9 is 1 by 3. So if you observe, in the left hand side of 3 as well as in the right hand side of 3, the functional value is same. So finally we have to conclude that the given function is continuous. This function is continuous function. How we check? We checked by taking the left hand side and right hand side functional values for 0 as well as for 1 as well as for 3. The given function is continuous. Since it is continuous, it is differentiable function. So we need to find out the derivative of this function in all these regions. Before going to find the derivative, if you observe the definition of the function for x less than 0, see, if you observe the terms, all these terms are looks like the expansion of x plus 1 to the power 5. See, here we have 5x power 4, ఇక్కడ కూడా 5x ఉండాలి. So if this is 5x, we need to subtract 1 2x. So this can be viewed like x plus 1 to the power 5 minus 2x. See, if x less than 0, this is the function, and in the remaining cases, this is the function. We need to go with the derivative of this function. So in this case, its derivative is 5x plus 1 to the power 4 minus 2. And in this region, its derivative is 2x minus 1. And in this region, its derivative is 2 by 3 of 3x squared. 3 will get cancelled. So 2x square minus 8x plus 7, and for this constant it is 0. And in this region, See, for 10 by 3 it is 0, for x it is minus 1, and for this function we need to apply UV rule. First function into the derivative of second function, so that will be x minus 2 into derivative of the second function is 1 by x minus 2 plus second function log x minus 2 to the base e into derivative of this one is 1. Again, for x it is minus 1 and for 10 by 3 it is 0. X by 2 is 1. This one and this one get cancelled and you left with the log x minus 2 base e. So the derivative of the given function, if x greater than or equals to 3, it is log x minus 2 to the base e. So in every region the derivative of function is like this. Now try to check which of the following options are correct. See, if you see the first option, see, and then these are the values of f dash. The last option is given like this: f dash is not differentiable, x is equals to 1. F dash is not differentiable, x is equals to 1. So in these two regions, for x less than 1 as well as for x greater than 1, we have to check the derivative of f dash. F dash is not differentiable. So try to find f double dash for this region. So if you find f double dash is 2 here, and f double dash value is here, what is 4x minus 8. This is for x less than 1 and this is for x greater than or equals to 1. In the left hand region of 1, f double dash is 2. In the right hand region of 1, f double dash is 4 into 1 minus 8, which is minus 4. So in the left hand side and right hand side, the f double dash value is not equal. So f double dash not exist means f dash is not differentiable at x is equals to 1. So clearly option 4 is the correct choice. Then to check option 1, f dash has a local maxima at x is equals to 1. Whenever it has a local maxima, see, if you observe, to check whether f dash has local maxima at x is equals to 1, we need to observe its second derivative and its derivative. That means the second derivative of f in the left hand side and right hand side regions of 1. If you check, see, for x less than 1, derivative of f dash is positive. For x greater than 1, derivative of f dash is negative. This is the derivative of f dash. So derivative of f dash is once positive and once negative. Surely at 1 we have a local maximum. And in otherwise, if you try to draw the graph of f dash at 1, see, f dash in this region, this is f dash, in this region the function is 2x minus 1, so it is a straight line. And in this region, f dash is a quadratic, so it becomes a parabola. So somewhere we have parabola here. And if you check for x is equals to 1, its value is what? 2 into 1 minus 1 is 1. And for x is equals to 1, here also its value is 2 plus 7 minus 8 is 1. So this is the common point for those two, line and the parabola. So clearly this is a sharp corner. So at that point we will have a local maxima for f dash. So option 1 is also a correct option. Then we need to go with check for the option 2 and 3. F is an increasing or minus infinity to 0. See whether it is continuously increasing or not in this region. Minus infinity to 0 means for x less than 0. In this region, if you observe the derivative of f, the derivative is this one. See, if you observe, this derivative value is 0 for two values of x. If it is 0, then you will get two values for x in the region of x less than 0. So this function is not an increasing function. So this is a not correct option. So we don't have to select this option, right? Then we need to check the remaining option is whether f is onto or not. See, clearly if you observe the definition of the function is defined from the minus infinity to plus infinity. This is for x less than 0, this is for x greater than 3. So from minus infinity to infinity, the function is defined. So from that it is clear that f is an onto function. So for this function, for this problem, your correct options are option 1, option 2, option 4 and option 3 is not a correct choice. So to identify the correct options, we first found the derivative of f and then with the derivative of f, we concluded the correct options are 1, 2 and 4. So this is the question asked in JEE Advanced 2019 paper 1.